Okay, we're back. So we're going to move on with the long bones. Now, at the end of the long bones, which is the epiphysis, you have the red bone marrow. And the red bone marrow is where erythrocytes, which are red blood cells, are formed, and some white blood cells as well. There are other places in the body white blood cells are formed, but they are also formed in the red bone marrow. That is different from the bone marrow in the middle of the bone. Um, and around the bone there's also, it's called periosteum, and this is like this tough covering. So endosteum is on the inside of the bone. It's kind of like a tough covering on the inside that lines the medullary cavity. Periosteum is what covers the outside, and the periosteum has blood vessels, lymph vessels, nerves, and it is necessary for growth, repair, and nutrition. So if you ever get kicked in the shin and you realize how badly that hurts, that's because of your periosteum. And your bone in your shin is so close to the surface of your skin that when you get hit in the shin, it really hurts. Whenever we would do bone marrow biopsies, we would have to numb the periosteum first. So the doctor would have to put a long needle in, and he would put in xylocaine, and he would numb all the way down to the bone, and then he would make sure that he numbed that periosteum, because that was the most painful part. If you were going to do a bone marrow biopsy, of going through that periosteum, it would be really, really painful if they didn't numb it. And then you have what's called articular cartilage. Now, if you think about articulate means moving against. So the articular cartilage covers the epiphysis and acts as a shock absorber to the joint. So if you think about the end of your shoulder, your humerus, which ends at your shoulder and your elbow, there's that cartilage on the inside. That's articular cartilage. It's that shiny white material. You can see it on a chicken bone, guys. So that's articular cartilage. All right, growth. So growth in length is from the center of the diaphysis towards the epiphyseal extremities. So growth in length doesn't happen at the ends. It happens from the center. The ossification happens towards the center of the bone, and that's what makes your bone grow. So if you look at a diagram of a bone, you can see that shaft, and this is where this growing ossification happens, in the shaft of the bone, or the diaphysis. As this bone ossifies, the diaphysis gets longer and the epiphysis moves apart, and that's what makes us taller. It also increases the circumference. So if you were to look at a little child's bone, obviously as they grow, not only does the bone get taller, but it gets wider. So as I said before, osteoblasts are the cells that deposit new bone to the outer surface of the diaphysis. So blast always means forming or new. The periosteum is what supplies the osteoblasts with blood. Okay, every single cell in your body has to have nutrients and blood. Every single one of them. So this is how in the bones it works. Bone material dissolves from the central part of a diaphysis, which is what forms the medullary cavity. And those bone destroyers are called osteoclasts. So clast always means destruction. So osteoclasts are the bones that destroy. Okay. So as bone material dissolves from the central part of the diaphysis, it forms that medullary cavity where bone marrow is located. And again, the endosteum lies on the inner surface of that cavity. The osteoclasts secrete an enzyme that breaks down the bone. So say you need a level of calcium in your body. It's the osteoclasts that break down the bone to release calcium into your bloodstream. So even though you have osteoclasts that are breaking down bone in the center, the length of the bone shaft keeps growing. Okay. It keeps growing through ossification. Bone also is renewed through remodeling. So old bone tissue is broken down and removed by osteoclasts, and the new bone is laid down by osteoblasts that replace the old tissue. For instance, if you break a bone, it's your osteoblasts and your osteoclasts that are going to remodel. So you break a bone, and the osteoclasts break down any tissue that's destroyed, or and they remove it. And your osteoblasts are what lay down the new bone to heal that bone together. So new bone growth can occur in a broken bone at any time. So it usually takes, 6 to 8 weeks. And it's kind of interesting. It forms almost like a blood clot. It looks like a blood clot. And then the bone starts, the osteoblasts start laying down the new bone cells in ossification. And it looks like on an x-ray like a bump. You can tell where somebody has broken a bone, and you can tell it forever, even though there's remodeling. So when you break a finger, you might notice that after it heals, there's a bump on your finger, but after a while it goes away. And that's because the new bone forms that kind of a bump, and then the osteoclasts kind of smooth it out. It's called remodeling. And finally, we're at bone types. So bone types, we have long bones, irregular bones, flat bones, and short bones. Long bones are pretty self-explanatory. Long bones are found in the upper, lower, and extremities, like your femur, humerus, radius, ulna, fibula, tibia. Those are all long bones. And they are needed to support weight and height. Okay. Flat bones are things like your ribs. Okay. Now, there's a little bit of controversy, but skull bones are considered flat bones, although some scientists consider them irregular. But they're flat. I've always considered them flat. You guys can make your own decision. Flat bones would be your ribs, your pelvis. Irregular bones are your vertebra. Your vertebra are your irregular bones. And you have short bones. Those are your metacarpals, your metatarsals. That's your fingers and your toes. And they allow for flexibility. If you had big, long fingers with big, long bones, you wouldn't have the flexibility that you have with the little short ones. And if you look at a hand, you can see, and feet, you can see that they're small, smaller, and then at the very end, the phalanges is the smallest. And that's how we're able to grasp things. Okay. I think that's probably we're going to end for lesson 1. And lesson 2, we're going to start with the different types of skeletons. I'll see you guys in class.